A carabiner. A carabiner is a metal loop with a spring-loaded gate used to quickly and reversibly connect components, most notably in safety-critical systems. The word is a shortened form of Karabinerhaken, a German phrase for a spring hook used by a carbine rifleman, or karabinier, to attach items to a belt or bandolier. The karabiner has been improved several times over the decades, making it more lightweight, reliable and durable. Use. Carabiners are widely used in rope-intensive activities such as climbing, arboriculture, caving, sailing, hot air ballooning, rope rescue, construction, industrial rope work, window cleaning, whitewater rescue, and acrobatics. They are predominantly made from both steel and aluminium. Those used in sports tend to be of a lighter weight than those used in commercial applications and rope rescue, often referred to as carabiner style or as mini-biners. Carabiner keyrings and other light-use clips of similar style and design have also become popular. Most are stamped with a "not for climbing" or similar warning due to a common lack of load testing and safety standards in manufacturing. While from an etymological perspective any metal attaching link with a spring gate is technically a carabiner, the strict usage among the climbing community specifically refers only to those devices manufactured and tested for load-bearing in safety-critical systems like rock and mountain climbing. Carabiners on hot air balloons are used to connect the envelope to the basket and are rated at 2.5 ton, 3 ton or 4 ton. Physical properties. Shape. Carabiners come in 4 characteristic shapes: oval, symmetric, most basic and utilitarian. Smooth, regular curves are gentle on equipment and allow easy repositioning of loads. The greatest disadvantage is that a load is shared equally on both the strong solid spine and the weaker gated axis. D. Asymmetric shape transfers the majority of the load onto the spine, the carabiner's strongest axis. Offset. D. Variant of AD with a greater asymmetry, allowing for a wider gate opening. Pair. HMS, specialized oversized offset Ds used in belaying. These are usually the heaviest carabiners. Locking mechanisms. There are 3 broad categories of carabiner: auto-locking, manual locking, and non-locking. Non-locking carabiners have a sprung swinging gate that accepts a rope, webbing, sling, or other hardware. Rock climbers frequently connect 2 non-locking carabiners with a short length of nylon web to create a quick draw. 3 gate types are common. Straight gate, the most utilitarian, and hence most popular. Wire gate, the lightest type with a strength roughly equal to the others, allowing more to be carried for a given weight. Wire gates are less prone to icing up than solid gates, an advantage in alpine mountaineering and ice climbing. The reduced gate mass makes the wire bales less prone to gate flutter, a dangerous condition created by irregular impact forces generated by the climbing rope or contact with hard surfaces in a fall which momentarily opens the gate. Locking. Locking carabiners have the same general shape as non-locking carabiners but have an additional mechanism securing the gate. These mechanisms may be either threaded sleeves, spring-loaded sleeves, magnetic levers or double gates. Screw lock have a threaded sleeve over the gate which must be engaged and disengaged manually. They have fewer moving parts than spring-loaded mechanisms, are less prone to malfunctioning due to contamination or component fatigue, easier to employ one-handed. They, however, require more total effort and are more time-consuming than twist lock. Twist lock have a security sleeve which must be manually rotated to disengage, but which springs closed automatically upon release. They offer the advantage of re-engaging without additional user input, but being spring-loaded are prone to both spring fatigue and the more complex mechanisms becoming bulky from dirt, ice, or other contamination. They They are also difficult to engage one-handed and with gloves on. Magnetic. Have two small levers with embedded magnets on either side of the locking gate, which must be pushed or pinched simultaneously to disengage. Upon release, the levers pull shut and into the locked position against a small steel insert in the carabiner nose. With the gate open, the magnets in the two levers repel each other so they do not lock or stick together, which might prevent the gate from closing properly. Advantages: a very easy one-handed operation, re-engaging without additional user input, and few mechanical parts that can fail. Double gate. Have two opposed overlapping gates at the opening which prevent a rope or anchor from inadvertently passing through the gate in either direction, but which can be opened by splitting the gates with a fingertip, allowing the carabiner to be quickly opened with and closed with one hand. The lack of a rotating lock prevents a rolling knot, such as the munter hitch, from unlocking the gate and passing through, giving a measure of inherent safety in use and reducing mechanical complexity. Certification. Europe recreation. Carabiners sold for use in climbing in Europe must conform to standard N 12275 to 1998 mountaineering equipment, connectors, safety requirements, and test methods, which governs testing protocols, rated strengths, and markings. A braking stress of at least 20 kN with the gate closed and 7 kN with the gate open is the standard for most climbing applications, although requirements vary depending on the activity. Carabiners are marked on the side with single letters showing their intended area of use, for example, K, B, and H. Industry. Carabiners used for access in commercial and industrial environments within Europe must comply with N 362 to 2004 personal protective equipment against falls from a height. Connectors. The minimum gate closed braking strain of a carabiner conforming with N 362 to 2004 is nominally the same as that of N 12275 to 1998 at around 20 kN. Carabiners complying with both N 12275 to 1998 and N 362 to 2004 are available. United States fall protection. Carabiners used for fall protection in U.S. industry are classified as connectors, and are required to meet occupational safety and health Administration Standard 1910.66 APC Personal Fall Arrest System, which specifies drop-forged, press-deformed steel, or made of equivalent materials, and a minimum braking strength of 5,000 lbf. American National Standards Institute, American Society of Safety Engineers Standard ANSI Z 359.1-2007 Safety Requirement for Personal Fall Arrest Systems, Subsystems and Components. Section 3.2.1.4 is a voluntary consensus standard. This standard requires that all connectors, carabiners support a minimum braking strength of 5,000 lbf and feature an auto-locking gate mechanism, which supports a minimum braking strength of 3,600 lbf. Rescue. Minimum braking strength requirements and calculations for rescue carabiners are set out in National Fire Protection Association Standard 1983 to 2012, edition Fire Service Life Safety Rope and Equipment. The standard defines two classes of rescue carabiners. Technical use rescue carabiners are required to have minimum braking strengths of 27 kN gate closed, 7 kN gate open and 7 kN minor access. General use rescue carabiners are required to have minimum braking strengths of 40 kN gate closed, 11 kN gate open and 11 kN contains minor access. Testing procedures for rescue carabiners are set out in the SDM International Standard F 1956 Standard Specification of Rescue Carabiners.